This lesson is going to show you how to complete the square. Completing the square is a method that can be used to solve quadratic equations, which is also how the quadratic formula is derived, or to rewrite standard form as vertex form. So you may recall that we looked at this when we were discussing factoring. We know that if we square a binomial, we'll end up with the first term squared 2 times the first term times the second term, and the second term squared. So for each expression we are given, we will look to see what is needed to create a perfect square. So we're going to be using that idea a lot. And I've given you an example below that shows two equivalent expressions. X squared plus 2x turns out to be the same as x squared plus 1 squared, x plus 1 all squared minus 1. And you can, of course, verify this information by looking at the expansion, right? We know that this will become x squared plus 2 times x times 1 plus 1 squared, which is 1, and then we have minus 1 at the end. And then we're left with x squared plus 2x, because a plus 1 and a minus 1 subtract out. So we know that they're correct. The question is, how do we get from this point to this point? We can see going the other way around is just a matter of expanding and simplifying. But to go from the top line to the second line, we need to use the method of completing the square. So we're going to take a look up here just for a second and write this as x plus a letter. So we'll call it x plus d squared, just so we can look to see what that looks like a little more specifically, because that's our common form. So that's what our perfect square looks like. And what I want you to really take note of is this middle term here. So it turns out the middle term is always 2d, that coefficient. So if we know what 2d is, then in order to create a perfect square, we just need to figure out d squared. So let's go back to our example below, where we had y equals x squared plus 2x. So in this case, we have this value here of 2, and 2 is what is equal to our 2d above, right? That's the b term from our standard form. So 2 is 2d. So what does that make d? Well, that makes d equal to 1. So if d is 1, what is d squared? Well, 1 squared is 1. So it turns out what we need to have a perfect square is to add the value 1. But of course, I can't add something without changing it, so I have to both add and subtract 1, so that I'm actually really just adding 0. But this now is where I get my perfect square. You can see that what I'm left with here, this section here, is what we had here. So that means we have x plus 1 squared minus 1. And that's the method we're going to use. You're going to see a couple of examples as I work through them. So here's our first example. We're given this expression or equation, y equals x squared minus 6x minus 7, and we're going to rewrite it in vertex form. So we're going to go through those steps that you were shown very briefly on the first slide, and I'm going to go through them a little bit more slowly for you and with a little bit more detail. So I need to figure out what is required in order to have a perfect square as part of this. So what you want to look at is the first two parts here. And often when I do this, I'm going to make use of some square brackets, partly to help me visualize this, to remember, and it's going to also come in handy on the next example where your a value is not 1. So what do I need in order to make x squared minus 6x into a perfect square? So remember that your b term there, so in this case negative 6, is equal to the value 2d, because that's what my middle term is when I have a perfect square. So that means in this case that d is negative 3, right? 2 times negative 3 is negative 6. And what I need is d squared. And d squared, that would be negative 3 squared, which is positive 9. So it turns out that what I need is positive 9. Okay, so that means x squared minus 6x plus 9 minus 9, because what I add I must subtract so that I don't change anything. And my minus 7 is still there. Now I don't want the minus 9 to be inside the brackets when I actually look to create my square. So I will rewrite this now. X squared minus 6x plus 9 minus 9 minus 7. So now we can see that that first bracket part is going to be a square. The question is what goes on the inside. So let's remind ourselves quickly again. X plus d squared is x squared plus 2dx plus d squared. So the question is, what is d? But we've already done that work. You can recall, if you look back up here, that d is negative 3. So I'm going to put x minus 3 inside my bracket, and that's going to give me minus 16 on the outside, and that means that my equation is finished. I have the expression, or the equation from above, written in vertex form. And you might recall that now I can use this to figure out things like I could tell what the vertex is, right? So if I really wanted to know, then I could put the vertex, which would be 3, negative 16 in this case. It opens upwards. It has an axis of symmetry at x equals 3, right? So I can use all of that information that I know from vertex form, because that's the form that I've ended up with. I've got another example here. In this case, my a value is no longer 1. So I'm going to rewrite y equals 2x squared plus 28x minus 3 in vertex form. And the difference here is that when I look at my piece that I was putting in brackets before, I want to factor out, so think about common factoring in a way, but what I really care about here is factoring out the a value. So even if it wasn't a common factor and this would create a fraction, I would still do this. Okay, it'll work with fractions just like it does with whole numbers. So what I want to do here is I want to factor out this 2, because I want to be left with just a simple x squared so that I can create my vertex form. So I'm going to factor the 2 out. So I'm left with x squared plus 14x, because 14 times 2 is 28. Leave the minus 3 there. It has to keep following us through. So now I need to know what is my d value, or what is d squared specifically, because I need to figure out what to add and what to subtract. So 14 is 2d, which means d is 7. D squared is 49. So there's my d squared. So I get 2 x squared plus 14x plus 49 minus 49, because remember I can't actually change anything. I can only add 0. And as you'll recall, we only want this part here to be inside the brackets for when we create our perfect square. So what I need to do as I've done before, is move this minus 49 so that it's out of the brackets. But in order to do that, this has to be multiplied by this, right? Because this is inside the brackets, and BEDMAS tells us we must multiply it by 2 before we can do any addition or subtraction. So let's make sure that that gets put outside the brackets properly. 2x squared plus 14x plus 49 minus 2 times 49 minus 3. So now I can write this in my vertex form. So my x plus d, in this case, will be x plus 7 squared, and 2 times 49 is 98. We're at negative 98, and subtract 3, so minus 101. And there you have it.